Alright, this is the second part of this lesson. We're going to be looking at finite differences. You would have done this in grade 9 and grade 10, but we're just going to recap you on what's going on with finite differences. So they're the differences between the y values, and they just distinguish whether you're having something that's linear, quadratic, or even exponential now. So you can kind of like see if the first differences are the same, that means it's linear. If the second differences are the same, then it's quadratic. And then we're going to chat about it's not the third differences, it's actually the common ratio. Excuse me. Alright, so let's go ahead and do the difference table for this first one. So we always start from the bottom and move up. So we're going to do 15 minus 12. Yeah, that gives us 3. And then 12 minus 9. Which is 3. And then 9 minus 6. You kind of get the picture. Alright, so since the first differences are the same, what is it? And since is like 2 dots and then a dot underneath, and then therefore is a dot on top and then 2 dots underneath. It's linear. Yeah, it's going up by equal values, and we can see our x values are also going up by equal values. That means it's linear. All right, let's go ahead and try this one. And you kind of tell right away, well, first of all, the x's are going up by equal increments, which is perfect. If it's not, and they're kind of like wonky, like this y value, then it isn't a function. Like you can go and try to graph it in Desmos, it will most likely not be a function. Alright, so let's go ahead and check the first differences here, even though we know that this is definitely not going to be linear. So here we get 54, 31 minus 13 is 18, and then 13 minus 7 gives us 6, and 7 minus 5 is 2. So I'm not going to go and try the second differences here, because I can obviously see again that my second differences are not going to be the same. So we know it's not linear and it's not quadratic. Let's go ahead and check and see if it's exponential. So for exponential, that means you're pretty much doing the exact same thing that you did for your first differences, but instead you are dividing. So we're not going to subtract, we are going to divide. So we're going to do 85 divided by 31. So it's the same from the bottom up. So just like for subtraction, right, we do y2 minus y1. Same with this, we're going to do the second one divided by the first one. And for here we get 2.7. What about 31 divided by 13? We get 2.4. Uh-oh. I can already see that something isn't the same here, right? And then what's the next one? 13 divided by 7 is 1.9. So I can already see that is also not exponential. We will see some that are exponential and then some that are the same, but in this case it's not linear, exponential, or quadratic. So it's let's just say neither. Right? It's not exponential, it's not linear. Right? And so it's this, in this case it's neither. So since the first differences and second differences are not the same, and this is called what we call the common ratio. This is called the common ratio. So since the common ratio is not the same, it's not exponential. And you could say the same thing for since the first differences and also second differences are not the same. It is not linear or quadratic. Go ahead and press pause at any time too. All right, let's try this one. So again, we're subtracting. So 16 minus 18. Here we're going to get negative 2. 18 minus 16, that gives us 2. Minus 10, that's 6. Oh, already there. 10 minus 0 is 10. All right. right. First differences are not the same. Let's go ahead and check the second differences. So -2 minus 2. We get -4. 2 minus 6. Hey, that's -4. And 6 minus 10. It's also -4. So since the second differences are the same, so therefore we see that it's quadratic relation. All right, so a little summary right here. Be sure that your x values are going up in equal increments, so evenly spaced. Determine the first differences first by subtracting the y values. And if those aren't the same, then go ahead and try the common ratio. Because you should be able to see, maybe not, that the relation is going up by equal increments a second time. But if go ahead and try the common ratio. If it is a common ratio is equal, it is exponential. If it's not, then calculate second differences. All right, so on the back here, we're just going to be defining some relations. So just classify it's linear, quadratic, or exponential. So here we can see an x in the exponent. That means it's exponential. Oops. So if there's an x in the exponent, it's exponential because we have y to the b to the x. Quadratic is like ax squared plus bx plus c. And linears are mx plus b. Right, so this is definitely exponential. Go ahead and try these. Press pause, see if you can get them all. If you guess linear for this one, you're right. That has a 1 on there. This is definitely quadratic because there's a 2 in the exponent. Again, linear, our x has a 1. Exponential, since there's an x in the exponent. And lastly, again, exponential, there's an x in the exponent. All right, classifying what they look like as a graph, pretty easy. Linear, exponential, and quadratic. And then lastly, we are, again, looking at the first or second or common ratios and classifying the relation. So let's graph. So here we can graph. We can also see from the y values what's kind of going on. So if we go over 2 and up a quarter, up a half, up 1, over 2, up 2, over 2 of 4, this is our exponential function. And you can go ahead and let's check out the first differences here. So you do 0.5 divided by 0.25. Well, here we get 2. What about 1 divided by 0.5? That's also 2. What about 2 divided by 1? That's 2 as well. And what about 4 divided by 2? See, it's the same as the first differences, but instead of subtracting, you're dividing. We get the common ratio. And so we can see here that it is exponential. All right, and then lastly, let's go ahead and then graph this. So we're going over 6 down 12. I don't think it's going to fit. Let's change this. Let's go down like by 2's here and 1's here. So 1, 2, 3, 4, 5, 6, and then 2, 4, 6, 8, 10, 12. That fits. Over 4 and down 8. So 2, 4, 6, 8. Over 2 and down 4. 0, 0, over 2 and up here. All right, that looks like we have a line. Again, you can go ahead and check the first differences, but this is a linear function. Right, and then complete the table of values, the difference tables. So here we definitely have to do our difference tables. All right, let's go check that. So 7 minus -5 is happening here. So you're subtracting. Watch out for that double negative. Negative 5 minus negative 9, we get 4. Negative 9 minus negative 5, we get negative 4. And negative 5 minus 7, we get negative 12. All right, so let's go check out the next differences. And hopefully you see here that exponential functions does not mean it's the third difference, okay? It's not the third difference. For exponential functions, we're looking for that common ratio that's happening. So this would be our first difference. This would be our second differences. So there we can see that therefore the relation is quadratic. Yeah, since like y2 minus y1. Here we're looking at y2 minus y1, our second one minus our first one, our third one minus our second one, and so forth. But here, can you kind of guess what it's going to be? Well, hopefully you jump right to it, and it's y2 divided by y1. So it's our second divided by, so 25 divided by 5. So we get 5 here. I like to start from the bottom so I don't miss any, but you can start from wherever you like. Just always know it's the second one divided by the first one, or minus, right? 125 divided by 25, we get 5. 625 divided by 125, we get 5 as well. And 3,125 divided by 625, we get 5. It's a common ratio. So therefore, the relation is exponential. All right. Have a great day, guys, and we'll see you on Friday. Another video will be coming up for Thursday's class as well.